In the previous session, we have looked at how to use t-test as well as ANOVA to analyze continuous variables. Now, let us look at how we can study the relationship between two continuous variables using correlation analysis. To describe the degree of linear relationship between two continuous variables, we can look for the correlational coefficient, or what we call R. R would lie between the value of -1 and +1. A value that is near to 0 would mean that there is no linear correlation. On the other hand, values that is near to either positive or -1 mean that there is strong correlation. The negative sign would mean that the two variables are inversely correlated, when a positive sign would indicate that the two variables are positively correlated. Let us look at an example of height and weight. If you were to do a scatter plot of a group of people's height and weight in a chart like this, you will see a distribution similar to this. But how do you know whether there is a correlation between height and weight? You can look for the R value as well as the P value when you look at the Pearson correlation. The p-value in this case is significant because it is less than 0.05. In fact, it is less than 0.001. The R value in this case is relatively high. It is 0.807. This is a positive value, indicating that the relationship between height and weight is positive. The higher the height, the higher the weight. And if you look at this table to look at the strength of the linear relationship, you can see that it is a very strong linear relationship because the R value is more than 0.8. Moderately strong relationship will have a R value of between 0.6 to 0.8, when fair linear relationship will have a R value of between 0.3 to 0.5. Anything less than 0.3 would indicate a weak or poor linear relationship. In this case, the relationship is strong. However, always remember that correlation does not mean causation. What is the difference? Correlation simply means that these two variables are associated with each other. However, one variable need not necessarily have a causation effect on the other. If we look at a separate example, for example, if you look at the GPA of a group of students and the height of a group of students. For example, if you were to find a strong correlation between the height of a student and their GPA, you can say that for some reason they are associated. However, being tall does not necessarily mean that you will have high GPA. And having high GPA does not necessarily make you tall. This is what we meant by correlation does not mean causation. Now, let's look at examples where the dependent variable is categorical. One commonly used test is the chi-square test. This test is used to test for association between categorical variables. For example, if we want to see whether there's association between gender and snoring status, we have a record of various subjects in terms of their gender and whether or not they snore. The null hypothesis is that there is no association between gender and snoring status. Of course, the alternative hypothesis would be that there is an association between gender and snoring status. The chi-square test would involve plotting a cross table, looking at the number of female who does not snore, and the number of female who snore, the number of male who does not snore, and the number of male who snore. When a chi-square test is being run, a p-value will be generated. In this case, the p-value is 0.065. This p-value is more than 0.05. So we conclude that there is no association between gender and snoring status. Note that the magnitude of the p-value does not necessarily indicate the strength of the association, if there is any, between the two categorical variables. Use this next few slides to practice on Minitab the various tests that we have shown. Now, let's try and test yourself to see what type of test would be appropriate for the following examples. The first one, if you want to compare the crispiness of Lay's versus Pringles potato chips, what type of statistical test would you use? You will use the two-sample t-test. In this case, the dependent variable that is being measured is the crispiness. The independent variable is the type of potato chips. Since you are comparing two different samples, you will use the two-sample t-test since they are independent from each other. Second example, to compare the moisture content among 4 different brands of bread. In this case, the dependent variable measured is the moisture content. The independent variable is the brand of bread. You will use the one-way ANOVA. Why? Because you have 4 different brands of bread. You cannot use the t-test because there's more than 2 samples. Therefore, you will use the ANOVA. This is a one-way ANOVA because there's only one independent variable. In this case, it is the brand of bread. Third example, to correlate the viscosity and water activity of a fruit syrup with different formulations. In this case, you will look at correlation coefficient because you are looking at 2 continuous variables that you want to correlate with each other, viscosity and water activity. In this case, you will look at the R value as well as the P value when you look at the Pearson correlation. Next example, to study the effects of pH and temperature on the stability of cake. In this case, the dependent variable being measured is the stability of the cake. But you have 2 different independent variables, pH and temperature. Therefore, you will use a two-way ANOVA. Next example, to compare the sensory evaluation score of a drink by the same pool of participants before and after the addition of a particular preservative. In this case, you will use a PET-T test. The dependent variable in this case is the evaluation score, and the independent variable in this case is the preservative. Because you are measuring the evaluation score before and after the addition of the preservative in the same pool of participants, this will warrant the use of a PET-T test since this is matched sample. The same participant will evaluate this drink before the preservative is being added and after the preservative is being added. Therefore, this score cannot be considered as independent since it's rated by the same participant. Therefore, it is the PET-T test. Last example, to examine the association between gender and the type of cheese preferred. In this case, you will use the chi-square test. You will plot a 2x2 table. One side will be gender and the other side will be type of cheese preferred, and you will generate the p-value to see if there is a significant difference. If the p-value is significant, then you can say that there's an association between gender and type of cheese preferred. However, you must always remember that there may not be a causation effect. It is simply an association.